In order to analyze and visualize data, this code imports a variety of Python libraries, including pandas, numpy, datetime, time, and matplotlib pyplot. A number of modules from the keras library are imported for the purpose of building neural network models. In addition, the code imports modules for training, evaluating, and loading models. Data normalization is completed using scikit-learn's min-max scaler. The ticker variable is set to AAPL, and the date ranges are defined. Once the data is read from a CSV file, it converts the dates into the correct format. Data is then made more usable by removing the date column. To retrieve stock data from Yahoo, this code imports the pandas datareader library's datareader function. In the next step, it uses this function to create a data frame with the ticker, start date, and end date specified. Last but not least, it removes the ejclose column from the data frame, with the potential to adjust other columns in the future. By using this code, we create a column called prevClose that contains the previous day's closing prices in the data frame called df. Afterwards, the modified data frame is displayed for the first 5 rows. Data frame df is created with a new column named wrap. Here, you can see how close the current value is to the previous day's value divided by the current value. It assigns each row in the data frame with its corresponding row in the wrap column as a result of this calculation. The following Python code retrieves the first 10 rows of a data frame. In this Python code, the first and last rows of the provided data frame are displayed, containing a summary of what they have to offer. There are 2 new columns in the data frame df created by this code, mvav short and mvav long. This column is calculated using the rolling mean function, which takes the close column as input and calculates the average for a defined window size of 5 and 50. In the original data frame, these new columns can be used to track short-term and long-term moving averages of close values. This Python code retrieves the top rows of a data frame, which is a table-like data object that contains multiple rows of data. Default is 5 rows. The number can be changed by specifying the number in parentheses. As of 2020.12, the df data frame contains values for the mvavg short column. In the df data frame, the open column is printed for the dates between 2019-12 and 2020-11. As a final step, it prints an average of the dates between 2019-12 and 2020-11 in the open column. A variable named df is created by selecting all rows from index 50 to the end of the data frame. This modified data frame's index is also printed. As suggested by the warning, this operation should be done only once. As a result of this code, 3 data frames are created, a train with all rows in the original data frame, and a test with the last 300 rows, and a df with all rows. A length will be printed for the variables train, test, and df in this code. Based on the input data and parameters, this function calculates the gross yield percentage and the annual yield percentage. The calculation of gross yield is based on the input data frame and a specified parameter v, and the output is converted to percentages. Afterwards, the function returns a pair containing the total and annual gross yields. A dataset is provided in this Python code, and offset copies are created according to the specified window size. Hence, the original data becomes shifted in a new dataset. Incomplete rows are then dropped from the new dataset before it is finally returned. It simplifies a dataset by calculating the minimum and maximum values, and then converting them to 0 or 1. By taking in a data frame that contains high, low, open, close, volume, and moving average data, it creates a data frame that has values scaled between 0 and 1. Next, it builds a sliding window of size 4 for predicting future values, and then converts the data into NumPy arrays. A dataset XDFW and YDFU is split based on mtest into 2 parts to create 2 train and test sets. Initially, a machine learning model is trained and then tested. In this code, a recurrent neural network RNN has been used to process sequential data using the long short-term memory architecture. A window of data with features is taken as input shape, and 3 LSTM layers are used along with 3 dropout layers. After adding 2 dense layers and setting the loss function and optimizer, the model is compiled before returning. An LSTM model is trained with a specified window size and 6 features using this code. Data is divided into training and validation sets in order to train the model over 100 epochs with a batch size of 30. A graph is displayed to show both training and validation sets' loss values. Assigns a prediction to the variable ypr based on the values in the input data xtrain using the trained model. Plotting the two lines ytrainw and ypar onto a plot of a specified size is achieved by using this code. Besides adding a legend, grid lines, and a title, this also adds a legend and grid lines. In the end, the plot is displayed. In this code, a trained model makes predictions on a given dataset xtestw and stores the results in a variable ypred. Using the first-order difference between elements in the ypred array, this code adds a maximum value to elements in the resulting array, LSTM, which is either 0 or the sign of the corresponding element in V. Python code that creates a 30 by 10 figure Xian. The figure shows three different datasets, ytestw, ypred, and LSTM, along with a 20-point font legend. The code also sets a title for the figure, as well as adding grid lines to the axis. This is followed by the display of the figure. In general, the code shows the relationship between the actual and predicted data points, as well as one vector called LSTM. By creating a vector of ones, the test array's size will be equal to the one vector created in the code. By checking if the open values are greater than the values in the mv-avg short and mv-avg long columns, two Boolean vectors are generated. The code calculates the gross portfolio based on a data frame and a weighted set of inputs. Multiplying the weight by wrap and adding 1 to it creates the weight. Afterward, it multiplies each weight value up to that index. At the end of this analysis, a list of gross portfolio values is generated for each index. Using pyplot, this code creates a graph with a width of 30 and a height of 10. Using the test variable as the basis, the program plots 4 different portfolios using different methods: buy and hold, 5-day moving average, 50-day moving average, and LSTM. In order to display the graph, a legend is added and a title is provided. The code prints a string containing information about the test period, starting and ending values, as well as information about the dataset. Following that, the information about different investment strategies is added to 2 empty data frames.